Okay. Okay, listen here. In the last class, we have started discussing about chemical bonding. Okay, so in chemical bonding, we have started discussing about Lewis dot structure, done. Types of bonds, done. Next, formal charge. What is the formula of formal charge? Okay, formal charge equals to number of valency electrons in the free atom minus plus everyone got that formula? Yes. Okay, so try to attempt it on 2-3 questions. For example, take this a question like don't do now, just write it in your books. Okay, see ozone means we are writing O3 now. Okay, so I am writing like this, O3 like O, otherwise take the question whatever they have mentioned, it is better to take same thing. So try to give the numbers for these 3 things. Once again you solve it if you haven't solved. Like NO2 they have mentioned with this structure. Okay, now try to give the formal charge for 1, 2, 3 atoms. Okay, you do it. The next we have started discussing about hybridization. Before that we discussed about Fazan's rules. What are the 5 rules I told you? Cation should be, I will say, you just say yes or no, that's it. See, Fazan's rules explains the covalent character for ionic compounds. First thing is done. Next one. For a covalent compound, if cation size is small or more positive charge on cation, that result to have more covalent character. With respect to anion size should be large, or charge should be more, negative charge should be more, then the resulting compound will be having more covalent character. This is done. Okay, yesterday I haven't given you one example, this one. Just take CuCl and NaCl. Okay, from these 2 compounds, tell me which is having more covalent character, I am asking. CuCl. How you are answering this? Yeah, see here anion chloride ion, here also chloride ion, but cation here it is sodium cation and here it is copper plus ion. Now out of these 2 cations, how can we decide? Both of them have same charge. Okay, so in this case, what is the valency electronic configuration of copper? Like argon 18 over, next 3D, like 3D10, 4s1 it should be, but now it is 4s0 because plus 1 charge is there. Here it is like neon 3s1 should be there, that is 0 now. See, now this gas is this metal ion is having noble gas configuration. I mean noble, this is also noble gas only, not like that. But I am saying here it has 8 electron rule. What is that? 8. But here 18 electron rule. What is mean by 18? See, this is octet configuration we are looking here, but here 18, not octet, it is greater than that. 18 electron rule we are looking right now. So whenever there is 18 electron rule, you should say it as a pseudo inert gas configuration. This is inert gas configuration, and here for this metal, when there is pseudo inert gas configuration, that metal ion will have more effective nuclear charge. What I am saying, more effective nuclear charge. So if more effective nuclear charge, what happens? More effective nuclear charge for cation results to more covalent character. Therefore out of these 2 you should say CuCl is having more covalent character. Now what are the application I told you? So for an ionic compound, solubility will be more than the covalent compound. Next, for an ionic compound, melting point will be more. For an ionic compound, boiling point also more. So based on this, deciding which is covalent, which is ionic, we can give the applications for solubility, melting point, boiling point for the given compounds. Is this clear? Okay, so whenever I say something like this, if possible, try to give your work for your hand, like it will do its own work. Like, what are the applications of Fazan's rules? What? Tell me. Applications. Say solubility, melting point, boiling point, orders. That's it. Okay. Then next we started discussing about hybridization. See, anyways you have studied about hybridization like ammonia, methane, all these things you even studied in your class also, in your IP exams also. But here let me give you in a tricky way to do all these things. Before I start that, okay, see, we'll take methane. Yesterday I have did this, but anyways, you just follow me now again. I don't know whether you have followed yesterday or not, but try to do it now. See, carbon, nitrogen, oxygen are the central atoms, belongs to second period elements, right now. So second period elements like it is having 2s2, 2p2 electronic configuration. This is 2p3, 2s2, 2p3, here 2s2, 2p4. Okay, now if you write the orbital representation like this, you are going to represent. Okay, see, first 5 minutes give me some time, I will give you the theoretical concept, then we will do completely with the tricks. Okay, see, what is the valence electronic configuration? 4 electrons are there now, like this you are writing. See, in order to make like how many hydrogens are there here? 4. So each hydrogen has what is the electronic configuration? Like hydrogen 1 is 1. So how many electrons hydrogen is looking for? 1 more is required. So each hydrogen make 1 bond with the carbon. Like that, how many bonds are required? 4 bonds. So it means carbon should have how many unpaired electrons? 4. But here if you see, how many are there? 2 only there. So excitation of electron takes place here. So that you are going to get 4 boxes like this. Okay. See, I have written them separately here, but here I have written them with equally, like merged all those things. Now you have 1, 2, like Hund's rule you know now. How do you fill? 1, 1 electron first? Yeah, filled 1, 1 electron. So these orbitals are called now hybrid orbitals. What is that? Hybrid orbitals. What is the name of this orbital? This one? And now what is the name of this orbital? You don't say it as s orbital. You should say it as sp3 orbital. sp3 hybrid orbital. This is also sp3. This is also, it means they lost their identity. It means previously it is 2s, it is 2p. Individual ga unde. Now they all mixed up. They equally shared their energies. That's why we are giving 1, 1 electron to that. So now you should call them as sp3 hybridized orbital. So now how many sp3 hybridized orbitals are there? 4. So this is the basic concept you need to know. Now when I say these atomic orbitals, s orbital is spherical and p orbital will be like dumbbell, like this we have. But when I am saying these hybrid orbitals, what they will do? They will mix up. So now they will mix up, and how many orbitals are there? So 4 orbitals around the carbon. If this is a carbon, around the carbon 4 orbitals will be distributed equally. It means orbital means what, ma? Like probability of finding electron is maximum. It means in this region might be more electron density is present. See, if electron side to each other, what happens? Repulsions. So in order to minimize the repulsions, how we need to place them? With maximum separation, right now. So all of them are having electrons. So now you need to keep them in the 360 degrees. Now I am giving you 4 orbitals, like 4 pens I am giving you like this. Now what you will do? You will need to separate them like this with maximum angle possible, right now. So if you try to keep in the 360 degrees, I mean spherical shape, so it will be having like this. Now what is the angle that is possible? Here 109.5 degrees between all these bonds. They have minimum repulsions. If you try in any other angle, they will experience as more repulsions. So that's why tetrahedral angle means how much you are saying? Everyone got this concept? Yeah. So now here, this side 1 bond, this side 1 bond, this side, this side. Like that 4 hydrogens you are seeing. Okay, what is the angle now? 109.5 degrees. So same story applicable here also. Okay, but if you see, there is only 3 surrounding atoms. Okay, it means 2s. Like this we have now. 2p3 means like this. Okay, so this is p, this is S. So again they will mix first, they will redistribute their energies and they form sp3 hybridization. Okay, now this is what happens because 5 electrons are there. Now one hydrogen, second, third. Now how many sigma bonds we are seeing? 3 and one lone pair. These are not participating in the bond formation. Okay, so now hybridization number equals to number of sigma bonds plus number of lone pairs. Pair should be pair, lone pair. So how much it is? 3 plus 1. So it is 4. So you can say simply it is sp3 hybridization. Okay, but what is the geometry I told you here? Tetrahedral. See, 4 bonds unnai anukondi, then em anali? With sp3 geometry, sp3 hybridization, 4 bonds are there. You should call it as tetrahedral. Here it is sp3 hybridization, but how many bonds are there? 3 bonds. It means, again pens first. Okay. So let us say like this is a tetrahedral geometry you consider. Now what happening, these 3 bonds are there, but see ammonia means 3 bonds only there, na? One more position we have, only lone pairs. Is there any bond here? No. So just try to remove it. How it is looking? Pyramid shape or not? Yes or no? And here what we have? So you should say trigonal, pyramidal, like trigonal pyramidal geometry. So trigonal pyramidal geometry for which species? Anything that has sp3 hybridization with only 3 bond pairs. What I am saying? Anything with sp3 hybridization with 3 bond pairs and 1 lone pair. Is this clear? Okay. Now see, I just want to finish up water molecule also. Now water molecules, how many surrounding atoms are there? How many are there surrounding? 2. Hydrogens are 2. It means remaining 2 orbitals will be now having lone pairs. So one more bond also I should remove. See ma, if all bond pairs are there means tetrahedral. What is the angle? 190. Now in the ammonia case, electrons are there here also. Electronic geometry means that is made up of electrons. Okay, idantha confusion emoddu. Just tell me what is the structure we have here. When it will be ammonia case, sp3 hybridization with 1 lone pair. Now see, in water molecule same sp3 hybridization but only 2 surrounding atoms means you have 2 lone pair electrons. It means you are removing one more thing. Now this is a story, like here 1 lone pair will be there, here 1 lone pair will be there. Now how it is looking? V shape or bent shape I can say. Yes or no? Yeah. So now this is a story. So when it is? Now one more thing. Sir, what about angles? Here it is 109.5 I am saying. When it comes to this one, N are a pyramidal shape ma, not trigonal planar. Pyramidal shape means it is like this now. This won't be 120. It is around 107 degrees. How much? 107. So here angle is around 107 degrees. Okay, in ammonia what is the bond angle? 107. What is the hybridization we got? Please try to follow me for the next 20 minutes so that everything will be sorted out. Definitely you are going to get one question from this. Without this question, you don't see a question paper, whether it is NEET, EAPCET, whatever it is. Okay, next one, water molecule means you have something like this. Yes or no? So now what is the angle here you are going to see? 104.5 degrees. Now what makes the difference from here to here, here to there? This is sp3, sp3, sp3. But here 109, here 107, here 104. So here you should realize that I have only 2 electrons like this. Here also 2 electrons. If there is electron pair, this is pair of electron, this is pair of electrons. I am keeping close to each other. What happens? Repulsions. Okay. Now what I am taking, one atom I am taking. Atom has nucleus now. With that nucleus here 1 electron is there. Here one more atom is there. With that nucleus 1 more electron here we have. It means hydrogen electron. So if I make this bond, this is called bond pair electron. Yes or no? Yeah. These bond pair electrons are lying with the 2 nucleus. Means ikkada nucleus undi, ikkada nucleus undi. These bond pair electrons are shared with the nucleus of 2 atoms. Okay? It means attractions are there to stabilize that electrons. But these electrons are simply sitting on 1 nucleus. Yes or no? This lone pair and this lone pair. That's why lone pair repulsions will be more compared with the bond pair or bond pair lone pairs. Okay? Andukosame, when there is 4 bonds, what is the angle you are seeing? When there is 3 bond pairs and 1 lone pair. Here 107. See, angle is compressed or not? 109 becoming 107. It means what is happening? Angle is compressed. Why it is like that? See, these lone pairs will shows more repulsions like this. They will dominate. Therefore, these bonds, what they will do? Are vinton manak baad enduku ravi ani compress ayipote. So that's why that angle become 107. So by minimizing the angle, they become stabilized. So here if you see, here lone pair repulsions are there, more dominating. That's why they will try to occupy more space. If they are occupying more space, these fellows will compress. That's why it is becoming. Is this clear? So now there is something called valency shell electron pair repulsion theory. What is that? Valency shell electron pair theory. Once again tell me, what is that? Valency shell electron pair theory. So what it is says as? See, when there is lone pairs on the molecule, that lone pair repulsion seems to be more than lone pair pi bond, then lone pair sigma bond, then next pi bond, next pi bond, sigma bond. First, this is for complete extreme level. First, the basic thing you need to know is lone pair repulsion is more than lone pair, then next bond pair. So you just write this one line, this thing, this whatever the box I have highlighted. First, you remember this thing. First, whenever there is lone pairs, lone pair repulsions will be more than lone pair, bond pair. Then next list is bond pair. You just remember up to here. When the things comes, I will explain about this lone pair, pi bond, all those things. Are bond pairs are how many types, ma? Types. How many types? Sigma bond, pi bond. Out of that sigma bond and pi bond will show more repulsion than sigma bond. That is the story. Okay. Okay, next. See, if hybridization number are also considered to be steric number is equals to 2 out there, so we are going to get SP. What is that? SP. See, SP means 2 orbitals, na, it will be something like this. What is the angle you are going to see now? 180. This is around 180 degrees, right now? Yeah. So now, when it is equals to 3, you are going to see SP2. So it will be like SP2. Actually what we are doing is, you just consider a sphere, not circle. What I am saying? Sphere, like a globe, 3-dimensional space. You need to arrange these orbitals in that 3-dimensional space with maximum separation all the time. What I am saying, ఒక స్పియర్ లాగా షేప్ని కన్సిడర్ చేసుకోండి. నేను ఒక మాలిక్యూల్ చెప్పినప్పుడు దాని యొక్క ఈ ఆర్బిటాల్స్ అనేవి మ్యాక్సిమం సపరేషన్తో ఉండాలి. సో మ్యాక్సిమం సపరేషన్ ఎందుకు? బికాస్ దట్ ఆర్బిటాల్స్ మీన్స్ ఎలక్ట్రాన్స్ ఓన్లీ నా. To if they keep that electrons with maximum separation, they will have minimum repulsions, and a more stable molecule it will be. Okay, so now if it is sp2, see, if you consider this is a 3-dimensional space, how can I place them? Tell me. Like this one, and here one. Okay, so what is the angle here? 120 degrees. Is this clear, everyone? Yes. So now in this case, sir, what if I have only 2 bond pairs, 1 lone pair? Okay, example. See, here I am writing BCl3 ma. What is this? BCl3. And one more I am writing SO2. Okay, BCl3, here itself let's start with the tricks. What is the group number of boron? 13th group. 1. So 3 valency electrons. 3 electrons. Chlorines are how many? 3. Each chlorine required 1 electron. So it will make 1-1 bond like this. Okay, so 1, 2, 3. So it is sp2. So it is sp2. How many bond pairs are there? 3 bond pairs. Bond form చేస్తే bond pairs, form చేయకపోతే lone pairs అంతే. చెప్పండి. B sp2 now, what is our geometry? See, I can place them like this. Like this now. So chlorine, chlorine, chlorine. What is the angle? 120. Next, this one. What is the group number for this? Sulfur, 16. So 6 valency electrons. Like this? Okay. So each oxygen is divalent. So it makes 2 bonds. Yes or no? 16th group means 6 electrons are there. 2 more electrons are required to make octet. That's why it is making 2 bonds. So this will remains. This is lone pair, pi bond, sigma bond, pi bond, sigma bond. So when we are constructing the structure, what I am saying? When we are constructing the structure, you need to make that framework, that structure framework using sigma bonds only. With what? Sigma bonds only. So pi bonds do not contribute for structure formation. They just lie on the sigma bond. Sigma bond emo itla construct chestam ra. Pi bonds just what paina untadi itla. They just lie on it. So now how many sigma bonds are there? 1 lone pair. So consider them only for hybridization. So now hybridization number equals to number of sigma bonds plus lone pairs. How many? So 2 plus 1. So 3. It means it is also sp2. So sp2, but how many bond pairs are there? 2 bond pairs now. So sulfur central. 1 oxygen this side, another oxygen is this side. Sigma bonds are over. Pi bond, don't bother about it, just put it like this. Okay, now one more set is what we have here? Lone pair. So now what happens, see, structure lo, structure ikkada lone pair undi. Is there any bond at this top side? Like this? If there is a bond, you are saying it as trigonal planar. But here we don't have. So it is something like this, bent shape. What is this? Now bent shape is there. Now what about this angle? Will it be greater than this or less than this? Less than this, definitely, because these lone pairs repel with these pi bonds. That's why they will come closer, compressed. So angle becomes less than 120. So now what is the shape you should say here? Bent shape or V shape you should call. Okay, is this clear? Okay, next one. If I keep on writing like this, it will take lot of time. So let us summarize it very quickly. So try to listen to me as much as you can. First one is what? CO2 I have mentioned here. CO2, what is the group number for carbon? 6. Okay. 14. What is the group number for carbon? 14. So valence electrons are? 4. If 4 valence electrons are there, what is that? 4 valence electrons, 1 carbon make 2 bonds, 4 electrons means 2. How many sigma bonds are there in that? 2 sigma bonds. So 2 sigma bonds means it is sp hybridization. So if it is sp hybridization, see, sp means here at the center carbon, here one oxygen, here one, like a line. So you should call it as sp hybridization means you should call it as linear. What is that? Okay, next one. Next one more way of doing this. See, I will tell you that dots you got it now, number of central atom electrons. Other ways you follow this formula, hybridization number equals to, I told you yesterday, group number of central atom plus number of monovalent atom, number of monovalent atoms plus, see, one more thing, some molecules might be charged. If it is a cation, cation means what? Are we adding electrons or removing electron? Positive charge, so we are removing electrons. It means you should also remove that. Anion means what? You have added some electrons, it might be having more electrons. So if there is a charge like negative charge plus A, whatever the charge you have, you write here. If there is a positive charge, minus that charge, minus C. C means cation, A means anion. Are sulfate ion is there, ma? So tell me. Will give you, let's tell me, okay. Sulfate ion only you take. What is the group number of central atom? 16, but valence electrons are how many? 6 only you take, don't take 16. Okay, next, oxygen is monovalent or divalent? Divalent. So don't consider, we need to consider only monovalent. So is there any monovalent atom here? No, so 0 place. What is the charge here you are seeing? So minus 2 should I add or should I remove? That's what this plus A indicates. A means anion. Whatever the charge is there, that you need to add here. 2 by 2. So 6 plus 2, 8 by 2, 4. 4 means what is that? sp3. sp3. Okay. If it is sp3, you got hybridization, then we can construct the structure. Okay. Up to here it is clear now? Yeah. So what is the formula? Tell me once again, hybridization formula. Group number plus number of monovalent atoms plus A minus C. Plus A means anion charge, minus C means cation charge by 2. Okay, that's it. You got it, you write it. Okay. So now, we have discussed about sulfate ion now. Sulfate ion, what is the hybridization we got? sp3. If it is sp3, so sulfur you put at the center. How many surrounding atoms you have? 4. So you put 4 bonds. How many surrounding atoms are there, sulfate ion? 4. I'm going to try to be here at most, what is it? Concentrated. Okay. So how many oxygens are there? SO4 minus 2 means 4 oxygens are there in the surrounding atoms. 1, 2, 3, 4. Okay. Next, what is the charge you are seeing? Minus 2. Now, sulfur can make, how many valence electrons are there with the sulfur? 6 now. So, you make odd number of bonds with this, even number of bonds with the sulfur. Like 1, 2, over. So, what is the charge you are seeing? Simple, oxygen is divalent now. So, it can make pi bond. This one is making pi bond, this one also making pi bond. Now, remaining minus 2 charge, you put one over here, another one over here, that's it. Okay, like this you need to write the structure of sulfate. Okay, now keep it aside. Let me give you one more. Carbonate is there. Tell me fast, how can I do this? Carbon central atom 4 plus, these are divalent atoms, don't consider. Carbon, how many atoms are there? So here also we got sp2 first of all. So sp2 maximum orbitals are 3. Right now? 3. So here also 3 is there. It means all orbitals are having no bonds. So oxygen 1, oxygen 2, oxygen 3. So oxygen can make how many bonds? So put one oxygen with a pi bond. Okay, and what is the charge you are seeing on oxygen? So minus 1 here, minus 1 here. Is it valence, like satisfied everything, structure? Are minus 2 charge is there now? So one minus charge on one oxygen and another one here. Carbon balanced with the 4 bonds. Is this clear or not? Yeah. So now, like this. In tetrahedral structure, if 4 bonds are there, you should say tetrahedral geometry. 3 bonds are there means pyramidal. 2 bonds are there means V shape. Okay. Now after tetrahedral will get when we have 4, it means sp3 hybridization. When we have 5, it will be sp3d because p orbitals are how many we have in a shell, subshell? 3. That's why 3. After that you should go for d. Okay. So now d, when we have sp3d, 5 now. If this is a central atom, let us say P is a central atom, around this P, how many bonds should be placed? 5. So you put 3 like this first. Okay. Now, like this is my hand. This is the plane. In this plane, you are putting 3 bonds. This side one, this side one, this side one. So what is the angle between them? Sir, we have written now. Like that you write first. Okay. You just consider they are in the plane. Plane in the sense within the plane like this. Trigonal planar means within the plane. Now what is the angle we are writing? Now you put one above the plane, one below the plane. Like this. Like this. Are you able to imagine what you are doing? So trigonal planar is in this plane. Now you are putting one above and one below. Now let us change the color of that lines so that you will more perfect. So now see between these red color lines, what I am saying, not pink, red color lines, what is the angle? 120. That red color lines are called equatorial bonds. What is that? Equatorial bonds. Now these yellow color lines are there now. With that yellow color lines, what is the angle we have with this plane? So this angle is how much? 90 degrees. Right now? Yeah. So that yellow color lines are called axial. What is it? Axial. So in trigonal bipyramidal geometry, we have 2 lines. I mean 2 types of bond lengths. One is axial, equatorial. So this axial bond length is greater than equatorial. What is that? Axis ante xyz axis ani itla rastama manam. See if I say this is x axis, ee yellow color line along the x axis unnai ga. So can I say this as axial bonds? Yes or no? Yes, sir. So axial bonds are more bond length than the equatorial. Remember this. Next. Now take this PCl5. What is the group number for phosphorus? So 5 valence electrons. How many surrounding atoms? 5. By 2. 10 by 2. 5. 5 means what is the hybridization? sp3d hybridization. See, then this all 5 orbitals are filled with 5 valency bonds only now. 5 atoms are there here. So it means on each corner you put one chlorine like this. Like this. Okay. So these are 3 chlorines in equatorial, 2 are in axial. Up to here it is clear? Okay. So which bond length is greater? Axial bond length is greater than equatorial. So sir, all the time it will be the same story. It means when the surrounding atoms are there now, if all of them are same, always axial will be greater than equatorial. But if surrounding atoms, if they are different, we cannot say that whether they larger or smaller. But if all atoms are same, equatorial. Okay, next one. Do this HCl4 fast. S means which group? 16. So how many valence electrons? 6. How many surrounding atoms? 4 by 2. So 5. 5 means sp3 hybridization. sp3 means we should get sp3d hybridization. 5 we got sp3d. But how many surrounding atoms are there? 4. So out of 5, 4 are bond pairs. 1 is, got the concept? Out of 5, 4 is bond pairs, 1 is, it means in these positions, the 4 are occupied with bond pairs, 1 is occupied with, everyone got this? Yeah. So let us try to draw the structure. S, like this. How many positions I told you? Axial and equatorial. So now which is axial here? See, now whenever there is lone pair electrons, what I am saying? Try to place that lone pair electrons in equatorial position. In which position? Equatorial position. Sir, can I put here? Yeah, you can put. Or here, you can put. Or here, yeah. It's completely your wish. All of them give same structure. But they must be in which position? Equatorial. So, first lone pairs you place in equatorial. So, I am erasing this line and I am placing lone pairs first. How many bond pairs are there now? 4. So, 1 chlorine here, next here, then next, then next. Like this you will get the structure. Okay. From trigonal bipyramidal, what you removed? 1 bond you have removed. Therefore, you got something like this. So, this shape is called seesaw. What is that? Seesaw. What is that shape called? Seesaw. Seesaw. So, seesaw is also called as distorted tetrahedral. What is that? Distorted tetrahedral. Why we are calling distorted tetrahedral? Because 4 bonds are there means tetrahedral structure come. But along with that lone pairs are there now. So it is disturbing the tetrahedral structure. So you can say distorted tetrahedral or seesaw. Perfect for this? Yeah. Next one. Take this ICL3. What is this? I belongs to which group? 17. Boys, please participate. I belongs to which group? 17. So 7 valence electrons plus how many surrounding atoms? 3 by 2. Now tell me. 10 by 2. 5. So 5 means again sp3d. If it is sp3d hybridization, see how many bond pairs are there? 3. So out of these 3 bond pairs, 2 lone pairs. Out of this 5, how many bond pairs are there? 3. Remaining 2 are? Lone pairs. Got it? Okay. So now lone pair should be placed at? Equatorial. So place the I in between. 1, 2, 3, 4, 5 like this we have. So 2 places are positioned with? This is 1 lone pair, 1 more lone pair. So remaining 3 positions are occupied with? Like this. Is this clear everyone what we are doing? So what is the structure called? Like this. So what is it? T only now? Yeah, you can write it as T shape. Okay, next. You do it for this fast. ICL2 minus. Everyone, I am not going to explain now. ICL2 minus. Write the structure, tell me how many lone pairs are in equatorial, axial, all that stories. Done? I means what is the group number? 7. Place surrounding atoms. 2. What is the charge? Minus 1 means you add that. sp3d means 5 we got. Out of that how many bond pairs? 2 bond pairs. 3 lone pairs. Do you got how we are dividing this? Yeah. Next. I in the middle. 1, 2, 3, 4, 5. How many lone pairs we have? 3. So where to accommodate them? Okay, next. Cl. That's it. How it is? Like a line. So you should say it as linear. What is the angle here you are going to see? 180 degrees. Okay, fine up to here. Okay. Now, yeah, we'll go forward. But before that, I will test your IQ levels or how intelligent you are. Now, see. How many 90 degrees angles are there in the given structure? How many 90 degrees angles are there in the given structure? So tell me how you are counting. Arey, this is plane now. With this bond we have now. This bond is perpendicular at 90 degrees with how many bonds in the equatorial positions? Arey, ee plane lo enni bonds unnayama? Red color vi 3. With all that red color lines, this yellow color line is 90 degrees only now. Like that, how many are there? Above 3. Above 3 are there now. Above 3 90 degrees. Below 3 90 degrees. So how many 90s are there? 6 90s. How many 120s are there? 3 120s. 1, 2, 3. So they will ask a simple question like this also. Okay, so in trigonal bipyramidal geometry, how many 90 degrees? How many 90 degrees? 6. How many 120 degrees? 3. Okay, up to here everyone clear now? Yeah, let's move forward for 5, hybridization number 5. So with, let us say it for SF6. What is that? Do it fast. SF6 means 16th group. See, no need pen paper. Sulfur, which group? 6. So 6 valence electrons. 6 plus surrounding atom 6. So we got 6. All 6 are bond pairs. 0 lone pairs. Okay, you put sulfur in the middle. Okay, like you take your book, I mean, if this is a book, on each corner of this book, you put 6, 4 fluorines, like this. Okay, now one put above, below. Okay, like this and like this. Okay, clear everyone? Okay, now what is the angle between this red color line and this red color line? Abba, endukura babu inta stress తీసుకుంటారు మీరు? See, this is the book I am giving you. At the middle I told you to put sulfur. What is the angle here between these two? 90. So like that, how many 90s are there within the plane, within that red color? 1, 2, 3, 4. So 4 90s in the plane with above yellow color line. Above yellow color line. 190, second 90, third 4. 4 above 4, within the plane 4, below 4. So how many 90s totally? Above 4, below 4. Within the plane? So total? 12 90 degrees. Okay, next, how many 180s? 180 means like this.
6.
1 180, 2 180, 3 180. So 3. This top to bottom 180 degree, this one. Yes or no? 180 degrees means like this only, Nama. Again with this. Other than that, do we have anything extra? No. So how many 180s? That's it. That's your answer. Okay. You got this identifying angles or not? Next, let us take one example of, okay, ClF5. Tell me fast. 7 plus 5 by 2, 6. Hybridization number is sp3d2. So with this geometry we got this now. This geometry is called what? Octahedral. That is done. Now in this sp3d2 geometry, how many bond pairs are there? 5 bond pairs, one lone pair. Now what happens to this? See, in this complete plane you put bonds only. That above line, yellow color line is there now. In that you put a lone pair. So now what happens? You just imagine there is nothing like equatorial axial in octahedral geometry. What I am saying? In octahedral geometry there is no. That story belongs to trigonal bipyramidal, TBP geometry, trigonal bipyramidal. When you get hybridization number 5, trigonal bipyramidal geometry will come. In that we have axial, equatorial. Okay, best example is PCl5. What is that? PCl5. Now here best example is SF6. Now how much we got hybridization number? 6. 6 means it is sp3d2. So 4 bonds, 4 atoms like this one are in the plane. One is above, one is below. Out of that you put that lone pair electrons on this yellow color line or this one. Now what happens, tell me? Let us say out of this 5, 4 fluorines are in the plane, 1 fluorine is above the plane, below the plane what I am putting now? Lone pairs. Now see, square we have and one bond is above side, like a square with a above bond. Try to join them like this. Yes, so square pyramidal. What is that you should call? Square pyramidal. Okay, done. Up to here it is done. Next one is ICl4 minus. Do it fast. sp3d2, 4 bond pairs, 2 lone pairs. Now you put one above lone pair, below one lone pair. So now only your atoms are in the plane. Like plane is nothing but a square box, like a square now. So square planar. What is that? Square planar. Everyone got this? Yes, perfect. One last hybridization you have in the syllabus is, do it for IF7. 7 hybridization number, like 7 plus 7, 14 by 2 is 7. So if it is like this, you should call it as sp3d3. So sp3d3 means you should say pentagonal bipyramidal. Okay, like trigonal bipyramidal means 3, like triangle you have taken, you put one above, one below. Now here it is 7 means you take pentagon. Pentagon means? You take pentagon in the plane, put one above, one below. So it will be something like this. Like this. Okay, you put one above, one below. In between, middle. So here one fluorine, here one fluorine, next, like this. Okay, so now again, if I ask you, what is the angle between 2 fluorines of this yellow color? See, above, below also fluorines are there. But within the plane we have now, like pentagon means, like just in my hand I am taking pentagon. So now what is the angle between the pentagon, fluorines in the pentagon? From here to here it is 72 degrees. How much it is? 72 degrees. Between this pentagon and above one? 90 degrees. With this it is 90 degrees. Like that, how many 72 degrees angles are there? 1, 2, 3, 4, 5. So 5 72 degrees angles are there. Okay. Now how many 90 degrees angles are there? 5 bonds now, with 5 bond above 1. 5 90s, 5 90s. Total how many 90s? 10 90 degrees. Is this clear or not? Everyone? Following? ఎక్కడైనా ఆగిపోతే చెప్పండి, ఇప్పుడే డిస్కస్ చేద్దాం మళ్ళీ. ఎనీవన్? మాకు అడిగే ధైర్యం లేదు సార్ అని అంటారా? మిక్స్ do it for this fast. See, you just record everything. Okay. See, there is a mouse. Let us continue. tell me, answer me this, guys, please. Answer me this. SF6. What is the hybridization we got? SP. So what is the way we can find it? Group number plus number of monovalent atoms by 2. So it is 6 plus 6 by 2, 12 by 2, 6. sp3d. XEF6 means sp3d3. So sp3d3 means, but how many surrounding atoms we have? 6. But hybridization number is 7. Hybridization number is 7. But here number of atoms are 6. It means there are 7 bond pairs, 1 lone pair. So in this case, the structure you should say it as distorted octahedral. What is it? Distorted octahedral. So what is the structure of this XEF6? What is the structure of XEF6? Distorted octahedral. What about this C6H6? So this is nothing but our benzene ring. So in benzene ring, each carbon is sp2 hybridized. Next, PF5, PCl5, all is a. That's it. Okay, match the question here. Which one is our answer? That's it. Okay, next. Let us move forward with one more question. Yeah, tell me for this, what is a lone repulsions? Lone pair repulsions are more than lone pair bond pair. The next bond pair. Next one, what about this question you tell me? Try to read this. Consider the following molecules and tell me the false statement from the 4 options. So HOH bond angle in water is smaller than HNH in NH3. Is this correct? No. What is the angle here? It is around 104.5. Here it is 107. So this is true statement now? Yes. Yeah. Next one. HCH bond angle in CH4 is larger than, here it is 109.5. This is also correct. Next one. The HCH bond angle in methane and NH H in ammonia and water molecules are greater than 90. This is also true statement. The next, this one. The HOH bond angle is larger than HCH. Is this true? No. So your answer should be 4. That's it. Perfect. Next one. Answer me this. Next. Fast, answer it fast. అసలు పని చేస్తుందా? See, how can you answer this? Tell me, what is that formula I told you? Nitrogen, group number 5 plus monovalent nama. Is this monovalent or bivalent? Bivalent. Don't consider. What is the charge here? Plus 1 is there means? So remove 1 electron. So 5 minus 1 by 2. 4 by 2 sp. So this is sp. Similarly, you tell me for these two. But when it is in solid form, PCl5 exists in this way. Like it will be like PCl4 plus and PCl6 minus. Okay, if it is PCl4 plus, it will be tetrahedral. Here PCl6 minus is there now. See how many surrounding atoms are there? 6. So you are going to get an octahedral geometry here. Like 5 plus 6 plus 1. 12 by 2. 6 octahedral. So this is a story when it is solid form. Gaseous phase, liquid phase, it will PCl5 will be always sp3d hybridization with trigonal bipyramidal geometry. Here sp3 and sp3d2. Just remember this. Okay, next what about PBr5? It will be in the solid form, in the gaseous and liquid state same as PCl5, but in the solid state it will dissociates like PBr4 plus and Br minus. So again, what is the hybridization here? sp3. If it is sp3, geometry will be tetrahedral. Okay, remember. So Pi5 does not exist. What I am saying, Pi5 cannot exist. SF6 means octahedral we discussed. Next, XeO F4 you try once. XeO F4, just no need of pen paper. XeO F4 means 8 plus 4 by 2, 12 by 2, 6. Out of 6, wait, sp3d2 is done. Out of that 6, how many bond pairs are required? 4 fluorines are there, 1 oxygen also there now. So out of 6, 5 are bond pairs, 1 is lone pair. Okay, so now if we have 1 lone pair, where to place them? The top or bottom in the octahedral geometry. Okay, next one more pi bond is there now. So pi bond also you should place not within the plane. Within the plane means here this is like for book I told now. In the book you don't put in the plane of that book, plane of the square. Okay, so there you put only fluorines. Above you put what? Oxygen. Below you put what about this? XeF6 F4. Fast, 8 plus 4 by 2, 12 by 2, 6. sp3d2 octahedral, 2 lone pairs above and below. Within the plane we will get 4 bond pairs. Done. Everyone square, planar. That's it. Okay, now we have bond parameters. What do we mean by bond parameters? Like bond length, bond angle, bond energy, bond order, all this comes under what? Bond parameters. Okay, so now we'll discuss with the bond angle here first. What is the bond angle you have seen in ammonia? 107. In water molecule? 104.5. In methane? So what is the factor affecting there? Lone pair electrons. Lone pair repulsions are more. That is the reason. Okay. Now here I will give you 2 examples, bond angle examples, like H2O I am writing and OF2 I am writing. What are the 2 things I am taking? H2 and, so what is the central atom you are seeing? What is the central atom you are seeing? So now oxygen you put like this as a central atom. Okay, and here also you put fluorine over here and here. So now you need to compare these bond angles. Like let us say this is θ1 and let us say this is θ2. Now tell me what is the order between θ1 and θ2, which is greater I am asking. See, how can you decide the bond angle? Means the electron density at this center. This is what the angle we are looking now. So now tell me who is more electronegative between oxygen and hydrogen? So the bonded electrons are taken more towards oxygen side. Now what happens here? More electron crowd will be there. So if more electron crowd is there, what happens? More repulsions are there. In order to minimize that repulsions, we need to place that bonds with maximum separation. So that's why θ1 will be greater than θ2. Now what about θ2? Just see here between oxygen and fluorine, who is electronegative? So now that electron density is more taken towards, dragging towards fluorine. So here less population, like electron density is less. So it means they can have normal angle only. But here due to repulsions they will be taking separation. So θ1 will be greater than θ2. So this is one type of scenario. The next scenario you check here, OF2 I am taking, OCl2 I am taking. So now tell me here, what about the bond angle? Let us say this is again θ1 and θ2. How can you answer this? So now again look at this. See, again fluorine over here, again fluorine over here. Next here, chlorine, chlorine. See, how many lone pairs are there around the fluorine? Like this, Same story with the chlorine also. Okay, but what about their sizes? Chlorine is larger than? So if two large atoms are close to each other, what happens? Repulsions. That's why when size is bigger, when size is increasing for the surrounding atoms, they will try to be with maximum separation. So which is more now, theta 1 or theta 2? Theta 2. So here it is greater angle than this. Due to what factor? Size factor. Okay, you got these two examples? Yeah, make a note of it. Next, done up to here? Hare, what to write? Nothing, like here bond angle is directly proportional to size when the atoms are of same group elements. Like these are same group elements now? In this case. Here bond angle is inversely proportional to electronegativity of surrounding atom. Here more electronegative, less bond angle. Next, you just answer this concept you got now. Based on that, you should answer me this example now, fast. NH3, that is over, this one. Use some brain. Write the structures first. Write the structures first. Don't answer directly, just try to write the structures and try to analyze which side electron density is pulling. Done? Which one? Huh? NF3. Why NF? N, H, N. So what I told you? Electronegativity. Both different atoms now consider electronegativity. So this side more pulling, so more electron density, so bond angle will be more here. So theta 1 will be greater than theta 2, you can say here, because this side it will be going normal angle. Done? Next. Okay. So this story we discussed like 109, 107, 104.5 in methane, ammonia and water molecules. This is done. Okay. Look at this. There is a relation now. Do we have any lone pairs here? No. Here, 2 lone pairs. As number of lone pairs increases, bond angle so as number of lone pairs increases, bond angle for a same hybridized central atom. All of them have same hybridization now. sp3 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 only now. So with the same hybridization, if more the number of lone pairs, lower will be the band angle. That's it. Okay. Next one. See, when the central atom have regular geometry, once read this. Regular geometry means what? Regular geometry. All the side atoms are identical and there is no lone pairs on central atom. The bond angle is not affected by electronegativity. It means central atom what we have here?
Carbon.
Next.
Silicon.
Next.
Germanium.
Next.
Tin.
Ante then so if you see in all the things we have sp3 hybridization only. What is that? sp3 hybridization only. Do we have any lone pairs on any of this atom? Carbon, silicon, germanium, tin belongs to same group elements now. So now whenever we have a regular geometry means, see, with sp3 hybridization, what is the like structures we have possibilities? It can be tetrahedral, it can be pyramidal, or it can be bent like this now. So when we will get like tetrahedral, there should not be any lone pairs. If we have one lone pair, if we have two lone pairs, bent. But here do we have any lone pairs? No. So if there is no lone pairs, then you say that geometry as regular geometry. So in regular geometry, even if you change the atoms, the central atom or the surrounding atoms, there is no change in their bond angle. It will be always same. See, carbon, silicon, germanium, tin, whatever may be, bond angle will be fixed as 109.5 degrees. Okay, is this clear? Okay. Now I am placing the carbon fixed. Now I am changing these surrounding atoms. I am fixing the carbon, changing the surrounding atoms. In the first one is CCl4. Now tell me what about their bond angles? Same, fixed. How much it is? 109.5 degrees. Remember this concept also. Next. Yeah. Next comes with the bond length. What about bond length? Like equilibrium distance between the nuclei of two atoms. If A and B are the atoms, now the distance between these two nucleus considered to be bond length. Okay. Now what are the factors affecting the bond length? First factor is size of bonded atom. If bonded atom is small, bond length also small. If size increases, bond length also increases. Next, multiplicity of bonds. Single bond, double bond, triple bonds. As number of bonds increases, atoms comes closer, bond order increases, bond length. So as number of bonds increases, multiplicity of bonds increases, bond length decreases. Next, what about percentage of S character I told you? Like more percentage of S character, like triple bond has more percentage of S character now, so lower the bond length, you should remember. Next one, number of lone pairs and bonded atoms. Okay, we'll discuss with one example for this. Okay, so try to arrange them with the bond angles. Just follow the question. What they are saying, BF3, H2O and CH4, NO2. What about their bond angles? Bond length I will give some examples. First answer me this. What is the angle? 120. Here? 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 How to say this? What is the group number? How to put this? So now nitrogen you put here in the middle. How many valence electrons? 5. 1, 2, 3, 4, 5. So this side one oxygen, this side one oxygen and one lone pair here. So this is something like around like a straight line now, around S like 180 degrees you can consider. Okay. So based on that you can arrange them. That's it. You got the answer now? Yeah. So next one is, can you try this 1-2 questions first? remaining 3 will be like lone pairs. Like that, what will be your answer for the first question? You tell me. Number of lone pair electrons if I ask. 3, 3s are 9, 10, 11. So for first question your answer should be 11. For the second question, what is your answer? Only on central atom now. This is 2. Do you got the concept, like what makes the difference here? Yeah. So now for this question you answer me. ClF3. ClF3 will be 2. NF3 means 1. SF4 means 1. If you do, you will get the answer. Next, XeF4 means 2. So what is your answer? C. That is your perfect answer for this. Next one. Can you match this? ClF3, what is the shape we got? T shape. Next, SF4. BRF5. 7 plus 5 square pyramidal. XeF4. That's it. That is your answer. Just match it and tell me. What's your answer? A3. D. That's it. Next. Tell me for this. What will be your answers? Okay, but you got the concept now? You can solve these questions. Okay, in the study hour also you can do. Next one, let us start molecular orbital theory. What is this? Molecular orbital theory. Okay. See, when I say atoms and molecules, atoms are less stable than, that's why atoms combine to form molecule. See, I will tell you this topic in very simple manner. When two atoms are combining, what I am saying, two atoms are, we are going to get a molecule like this. Okay, let us say two oxygen atoms are there combining to give you O2. So this is molecule, these are atoms. So when these are combining, each atom have its atomic orbitals now. Please follow this, very important. Okay, so each atom has its atomic orbital. Tell me what are the atomic orbitals for oxygen? Like 1s2, 2s2, 4. For this one also 1s2, 2s2, 2p4. See, each atomic orbital of this atom and this atom will combine. What they will do? They will combine to form molecular orbitals. What they will do? Atomic orbitals will combine to form See, how many atomic orbitals are combining? 2. This one, this one. So 2 atomic orbitals. When 2 atomic orbitals combines, we will get 2 molecular orbitals. What I am saying? 2 atomic orbitals combine to give you. So one is called as bonding and another one is called anti-bonding. One is called and another one is called So now this bonding is indicated with sigma. What is this? Anti-bonding is indicated with sigma star if it is a sigma bond. So 1s now. So you should say sigma 1s, sigma star 1s. Similarly, same energy here, 2s, 2s. Sigma 2s. So what is that pi? Pi 2px equals to pi 2py. So if these are bonding, what are the respect to anti-bonding? Pi star 2px equals to pi star 2py. So now this is the energy order. What I am saying, this is the energy order. So what is the lowest energy? Sigma 1s. Next, there this is small difference you should make. Why it is happening like this means, whenever their electrons are less than 14, there is something called sp mixing concept is there. S orbital, p orbital mix because of similar energy, that results to this kind of scenario. Actually it should be like that every time. Due to that lower number of electrons, more nuclear charge, this is the scenario. So what it is coming first? Pi first, next sigma 2pz. Respect to anti-bonding, pi star px equals to pi star 2py. Last is sigma star z. Okay, now try to fill the electrons, 10 electrons. 2, 4, 5, 6, 7, 8, 9, 10. Okay, now bond order you find. Half into How many bonding electrons? 2, 4, 5, 6. Minus anti-bonding 2, 4. So 2 by 2. So bond order is 1. Between two boron atoms, one bond will be present like this. Okay. Now my question is for you. You need to calculate it for C2, N2, okay, and NO. You need to do all these things. What are the two orders you should remember first? Greater than 14, it should be sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi sigma 2px, pi 2py equals to pi 2pz. You can take like that. Sigma star 2p, pi star 2pz equals to pi star 2px. Next sigma star, that's it. Okay. Next, if less than 14, interchange that. First pi, next sigma. Okay. Now I will tell you one simple tricky way to answer all these things. See, if you do it for N2 molecule, you are going to get bond order as 14. Bond order as 3. How many electrons are there? 14 electrons means what is the bond order you are going to get? 3. Last chapter physics. Okay. If not, you just listen. See, they will give you two molecules. For example, BF3 they will say. So write its structure first. Okay. And the next one, you take anything like NF3 I am saying. NF3 means what is the hybridization? BF3 and NF3. What is the hybridization here? SP3. So it means one lone pair is there here. BF3 means what is the hybridization? SP2. So SP2 means what is this geometry called? Trigonal planar. What is a trigonal planar? 120 degrees angle. Okay. So who is more electronegative here? Fluorine. So fluorine will drag the bonded electrons towards itself. Same, it means dipole moment is like this. Here also fluorine will drag. Here also fluorine will drag. But the net dipole moment of this two opposite of this. So it means both of them are cancelling out each other. So mu value will be equals to 0. But here if you study, whenever there is a lone pairs, dipole moment will be always towards that. Okay. And between these two atoms, who is more electronegative? Fluorine. Here, fluorine. Here, fluorine. But see, this side and this side, same atoms are same now. That's lone pair. Here it is fluorine. So do they have same energies? No. It means they will cancel out exactly each other or not? No, they won't cancel out exactly. So here dipole moment will not be equals to 0, but here it will be equals to 0. Now the question will be like this. Which are the following molecules have dipole moment 0? So you need to answer it like this. Okay. Now I will tell you one tricky way to do for organic compounds. See, when it comes to GOC, I am going to say something called electron releasing groups, and one more is electron withdrawing groups. So on a molecule, if two electron releasing groups are there, what I am saying? Two electron releasing. I think you know with respect to this, it is ortho, this is meta, this is para, will say. Okay. So if the two attached groups, this is also electron releasing groups. Okay. So if both of them are either electron releasing groups or both of them are electron withdrawing groups only. What I am saying, both same. Either they should be releasing or they should be withdrawing. So in that case, if both groups are same,